How about now? There we go. Before I start, I wanted to thank Anna, Jacob, and everybody else in the JDD team. They've been great while I've been here, and I've had a lot of great Polish food. I've had a lot of great Polish vodka, best in the world, at least what I remember about it. All right. And a very, very lovely city here. As a matter of fact, my grandmother is from Poland, and what I learned last night was almost everybody's grandmother comes from Poland, it seems. And I do know a little bit of Polish. I'm not even going to try to say that. But unfortunately, the words I know usually get me slapped by women, especially at the bars. So about 2 months before I put this together, I took it upon myself as a personal challenge to try to learn enough Polish to translate my slides. So we'll give it a try. Translation services are very expensive, and I wanted to try to do this on my own. So I bring you the art of messaging, designing. Oh dear. Is that not right? I think oh dear. Well, you can at least listen to me. This reminds me of, there's, what do you call a person, the English word, a person who knows 3 languages? Do you remember? Trilinguist? Try for 3, so trilinguist. How about a person who knows 2 languages? Bilinguist, yes. How about a person who knows just 1 language? An American, yes. So, I was a bit aggressive in the abstract, the write-up that you have. And when I first timed everything, it ended up being close to about 2.5 hours. Given I have about 45 minutes to talk, thankfully we have the Kuluary conference, the unconference tomorrow, in which we can spend the whole day coding. And at the end, I have some suggestions of things that we can do. But so I tried to pick some of the stuff I thought was kind of that I get excited about and meaningful about messaging in general. One of the things I would like to do today as kind of goals is really kind of hopefully share my excitement about messaging. The use cases in messaging, for example, which we will go through. And just in case you don't know messaging or are not familiar with it, I thought it would be fun just to spend a little bit of time going through the JMS API and also just a little bit of coding. After all, it is a developers conference, right? So we'll do some coding in both Java and Groovy just to see how simple messaging actually is. For those of you who are using messaging now, it'll be a little bit of a review or kind of a basics, but we'll do that. Then I want to really get to the heart of what I want to talk about, and that's really messaging design. The syntax, as you're going to see in a little bit, is very easy. It's a very simple API. However, messaging itself, from a design standpoint, can be kind of tricky. How many queues should I have? How many listeners should I use? A lot of decisions. So we'll go through some of those kind of pitfalls, some design kind of techniques. And what I'd like to finish with is something that's kind of emerging, not quite production ready yet, but is RESTful JMS. And in here, I really want to talk about the differences between messaging and web services, and kind of show some of the work that's happening with RESTful JMS and RESTful messaging in general. Okay. All right. So there's 3 things that I love about messaging. The first of those is the fact that we have asynchronous communications. It's never having to wait. Okay. I can make a request to another component, send it to a queue, and I don't need a response. My response time is that quick. The other thing is guaranteed delivery. When I send a message to a queue, I'm guaranteed that will be sent. Now, we know that I can play around with message expiry and retry counts and stuff, but generally, I'm guaranteed that that message, regardless of system failures, will be received. And the third great thing is load balancing. This is the ability to do concurrent processing within messaging. Okay. So what I want to do is to spend a couple of minutes going over some use cases that kind of use these to see what's the big deal about messaging. Why is messaging so cool? How can it be used? The first obvious choice is for heterogeneous integration. In other words, we're tying two different technologies together. For example, Java and C#. Starting to become a lot more common than it was, let's say, 10 years ago. How do we make these two components talk to one another? I mean, there's a variety of ways. Web services is certainly one. But it's a lot simpler simply to use messaging. So we could put a message channel sending XML back and forth between these two components, and it doesn't matter anymore that one of them is C# and one of them Java. Okay? So that's my first easy use case. The second one is to reduce bottlenecks in a system. Well, you say, Mark, we're just Java shop. We don't have any other kind of components, so I really don't need messaging, right? Well, suppose that we just have Java components, component 1 and component 2. And kind of like the traffic that we experience every morning when the two lanes merge into one and it produces a bottleneck, so all the traffic backs up, same things happen here. So we can actually use the load balancing part of messaging to be able to convert our component 2 into a message listener, thereby tripling our throughput through the system. Okay? We could have as many listeners, message listeners, as we want, well, depending on our hardware. There are some limitations. But that's one of the other really great things. The other is end-user productivity. So we don't have any bottlenecks in the system. We're only using Java. Could I still use messaging? Sure. To increase end-user productivity. How about those reports that say that the user knows take a long time to run, 3 or 4 minutes. So the user enters it, and they always have to run this report in the morning. So they know that's the time to go out for a smoke, maybe grab a cup of coffee, talk about the game yesterday. Oh, wait, hourglass is back. Here we go. Yeah, well, with messaging, we can use asynchronous messaging to send a request saying I want the report. Less than a second later, I get a response back saying, request received. Now I can continue working on some other stuff, and pretty soon, 3 or 4 minutes, I get a notification message somewhere on my dashboard or some sort of notification saying, hey, your report's ready. Oh, great, I'll look at it in a second. I've just increased the productivity of that user just by using messaging. But there is my favorite use case for messaging, and that's what I call architecture agility. Okay. Architecture agility, and what I mean by agility is the ability to respond quickly to a constantly changing environment. So I define agility. So suppose we have a component that's sending a message to a queue, and we have 3 other components that are receiving those. Without taking down my system, I can remove component C completely. But wait a minute. I'm sending messages to that. Where are those messages going? They're in the queue. They're waiting. Guaranteed delivery. I'm guaranteed that whenever I bring this component back online, it will start receiving it. So I take it down for maintenance, or I use a third-party product instead, or maybe I just simply rewrite it, put it back into the system, and it starts receiving the messages. That's cool. So that's why I like messaging. Okay. So, I always hate doing the kind of the show of hands, but I'm just curious, how many people are currently using messaging or have used messaging? Wow. Oh, wow. Well, we can skip this part then, can't we? We do need to write a little bit of code so that we can actually receive the messages we're going to send in HTML. But this will be a little bit of a review then. Okay. So JMS supports two kinds of messaging models, what's called point-to-point and publish and subscribe. So the point-to-point messaging really has two flavors. The left-hand side here is really describing something called true asynchronous, or fire and forget. I may send a message to do some auditing or logging or a report request, anything that I don't need a response for right away. Boom. However, there are times, let's say you and I are communicating point to point, but I need a confirmation number, or I have to block and wait for a response. I can still do that in messaging. Even though I'm still asynchronous, decoupled, I could still do a request reply. Notice the two Qs on there, okay? There's a couple of interesting characteristics about point-to-point as well. The first, I can have as many receivers down here as I want to. So I could have 20 receivers all listening for the same message. However, in point-to-point, I'm guaranteed that only one of those receivers will receive the message. Okay? So if I'm buying, let's say, 100 shares of Apple stock, and I have 20 listeners, I certainly don't want to buy 400 shares of Apple stock, but only one of those listeners will ever receive that request. Okay? Good. Then we have the publish and subscribe model. On this one, I drew it upside down to kind of illustrate. This is more of a broadcast kind of mode. Here we have publishers and subscribers and also topics. Okay? This is used to broadcast any sort of information. For example, a really cool use case for this is, how many of you know in your production systems right now how many exceptions you get a week? Wouldn't it be cool to write an interceptor that every time an exception occurs, you send that exception inside a simple text message and publish it to a topic? And then I can have a whole bunch of different kinds of subscribers all seeing that same exception. So for example, right here, I publish that an exception occurred. This subscriber listens for all of those exceptions and simply does counts based on the number of exceptions for metrics. How many exceptions of which type have I received? Kind of just does a little counter. This particular subscriber filters on certain exceptions and then sends those via email to some sort of production support. That's a neat thing for messaging, for publish and subscribe. Okay? All right. So I have mentioned the word message about 50 times. Let's see what one looks like in JMS. A JMS message really consists of three parts. There's the header, which consists of two areas, and then the message body. So the header is two parts. The first, and this, by the way, is javax.jms.message object. So the first part contains a lot of standard JMS properties, routing, timestamps, and these have getters and setters associated with them. Get JMS timestamp, set JMS expiration, so on and so forth. Then we have this area here where we can set our own properties. Okay? So if we have an XML payload, we're sending an XML message, and I need additional information, such as the, let's say the name and security for the trader. Well, I don't want to add that to my payload. I can simply add that to the message properties area here. Okay? And then we have the message body itself, which in JMS there's 5 types. Text message, which was what we'll be coding here, something very, very simple. The easiest way to send XML or a string. Then there's an object message in which we can actually send a Java object to a queue and then receive a Java object. Be careful. What happens if we use an object message. Sounds pretty cool, doesn't it? I have Java. Right? This is JMS, Java Messaging Service. I have Java. I already have an object. It's pretty cool that I could just send that object straight to a queue or a topic, isn't it? I don't have to convert it into XML or any map or anything like this. It sounds cool, but it's not. First of all, I can't communicate with any other type of platform, can I? Because if I'm sending a Java object to a queue, what do you suppose my receiver has to be? Java. So much for the heterogeneous integration. Let's see. Suppose I have changed that object that I'm sending. Don't forget, messaging systems are decoupled. It's the beauty about messaging. I have a component here and a component here, and the two of them are in separate deployments. They don't even know about each other. They don't know what language they're in, where they are, but what happens if I use a Java object now? I have coupled my systems back together in a single deployable unit, because if I change that object over here, this receiver will break. So yeah, it's very bad. So don't use object message. And then there's a map and stream and bytes message for actually sending bytes. Tomorrow, one of the things I wanted to do during this keynote here, but didn't really have time, was to kind of send pints of Guinness, or let's say liters of vodka, to a queue and receive it. We'll code all that up tomorrow. It's quite a bit of coding, but we'll do that tomorrow at the unconference. Okay, great. So the JMS API is very, very, very simple. It really consists of a generic set of interfaces and then queue and topic specific. So these are the actual interface names. Per the spec, and we're going to code this two different ways, but per the spec, the JMS API specification, we have to get two things from JNDI: connection factory and our destination. Okay? Once we have a connection factory, we can get a connection. Once we get a connection, we can get a session. And once we have a session, we can create any of the message types, a message producer, and consumer. Okay? Now, you know, with JDBC, the transactional unit of work, the thing that we pool, typically is what? A connection, right? Here in JMS, it's actually the session that forms the transactional unit of work, which means applications will typically only have one connection, and then it will pool sessions. So it's really the session where all the work is coming from. Okay, good. If we're using queues, well, it's pretty easy. Just replace the word connection factory with queue connection factory. The destination becomes a queue, and that's it. Topics, replace the word queue with a topic. And again, with topics, we have publishers and subscribers. Look at how intuitive this is. A topic publisher interface and a topic subscriber interface. Queue sender, queue receiver. It's very intuitive. So, let's see, we are at a Java conference, so let's code some Java. Does anybody here actually code anything in Groovy? Awesome, we'll do a little bit of Groovy coding as well, okay? So we'll send a message in Java, and we'll receive it in Groovy, and kind of see how this works. Okay, so what I have here, I have ActiveMQ is what I happen to be using. It's an open source, I would say enterprise level messaging provider. I'm sure, there were a lot of hands raised for messaging. Is it mostly ActiveMQ out here, or JBoss messaging, or a whole variety of different ones? Which ones are you using? Oh, WebSerialMQ? Okay, yep, ActiveMQ, okay. I happen to be using ActiveMQ just because it is open source and it's kind of easy to download, and you can run all these examples yourself. So I've got a very simple class here. I don't think I can get this any simpler, can I? Public static void main try catch. Boy, this is very interesting. So I want to use messaging. The first thing I'm going to do on the sender is I'm actually going to use JNDI. So we need to establish an initial context. Let's see. No, I'm not writing Polish. I'm writing English, aren't I? Yes. Okay. So we get a new initial context, and this comes from the jndi.properties file in the class path. So good. Do you remember the two things that we get from JNDI? Q connection factory. So I can go and do a lookup. There we go. Tough time fitting this on the screen. Is that all fitting there? Good. So I actually can grab the factory, cast it, do a CTX lookup on my connection factory here, QCF. Okay. Once I have a connection factory, the API goes very simple from there. Connection factory gives me a Q connection. Cool. And let me bring that down here. There we go. Okay. So I just use the factory, I create a Q connection. Okay. The other thing I get from JNDI is a queue. So let's do that. We'll do a lookup, and I'm going to call this Q1, just because I happen to have it defined there in ActiveMQ. Okay. So I've got a connection factory, a connection, and part of, if you haven't done anything with messaging, part of what I want to do here is to show you how simple it is. Now, I'm using regular plain Java. I'm not using Spring with message-driven beans or MDBs through JBoss. This is just plain, simple, raw messaging. Okay. So once I have a connection, I can get a session. So I create a queue session. And the queue session, bring that down, takes, so connection, create queue session, takes two parameters. That tells me whether the session is transacted or not. We can do a lot of coding tomorrow on that kind of stuff as well, saying the difference is why you would transact sessions. That's another topic that I had on the list. And also the acknowledgement mode. We can go through all of those ones as well. Lots of stuff we can do tomorrow. Okay, so now I've got a session. I can now start my connection. So we start our connection. Oops, doing too much groovy coding here. There we go. Okay, so I start the connection. Now I just create a queue sender, right? So you can start to see the whole flow of everything. I need to send a message. So I create a queue sender from the session, create sender, and I pass it in the queue. Cool. Let's create a text message here. So I'm going to create just a normal text message, which is the simplest kind of message. Session dot create text message. And in here, I'm just going to say, hi, JDD. How's that? Okay. Can we get any simpler than this? Yes. And then I just say sender.send and send the message and close the connection. Good. And I'm done. It's all the steps that are needed. Now, when we use things like Spring or Mule, Progress Fuse, Service Mix, Camel, MDBs, message-driven beans, and EJB21 spec or 3.1 spec, we generally don't need to code all this kind of stuff. We already have the connection available to us. It's already in the initial context. But it's pretty simple code. So it's, let's save this here and go over here and let's run it. Let's see, go over here, and we just sent a message. Where is it? It's in Q1, right? Good, so it's just waiting there. Well, let's go get it. There's two ways we could do a receiver. There are asynchronous receivers and what are called synchronous receivers. Okay, so let's create a synchronous receiver in Groovy, just to show, you know, we could use other languages for messaging, and it just kind of makes it a little more interesting than continually using Java. So what I have here is a standard Groovy class. I'm calling it JMS Groovy Receiver. And I have a static void main. Again, doesn't do much. It's not very exciting. Before, the code that you just saw, we used JNDI. This time, I'm actually going to connect to MQ directly. Okay. So this is kind of confusing. Wait a minute. I can actually connect directly to MQ? Sure. If I say def factory equals new active MQ connection factory. By the way, I'm blind as a bat. I can't see anything I'm typing here. I forgot my glasses, so hopefully this will compile. And now I have to pass in the URL, TCP. I'm listening on localhost 61816. Okay. I could do this in Java as well. So, I thought in JMS I had to use JDD09. So how can I directly connect to ActiveMQ here? Oh, it's simple. So messaging providers come in two flavors. There are JMS providers, and then there are messaging providers like ActiveMQ, WebSphere MQ, Fiorano is another one, that have bridges built in. So ActiveMQ can talk to C#, C++, C, Perl. There's about 13 or 14 APIs that ActiveMQ has. So that allows me to send something in JMS and receive it in .NET. Okay, it does the translation itself. So by doing this, I can directly connect to ActiveMQ. But what's going to happen here? What's going to happen? My sender I can use with any provider. I can switch to OpenJMS, which is a Java-only provider. But here I can't. So that's one of the disadvantages, in my opinion, of connecting directly. But I just wanted to show you another way to be able to do that. So when we have a factory, I can create a connection. Whoops. Cool. Wow, don't need semicolons. Groovy is just so nice. Okay, so now I created a connection. Remember, from a connection, we also need a session, right? So I can say connection dot, let's create, let's create our session. Remember, it had false, which was whether it was transacted or not, and then my acknowledgement mode, which I'm just going to use auto-acknowledge. Good. So I've got a session. Let's see, I need a queue, don't I? So I'm not getting it from JDD09, I'm getting it from ActiveMQ directly. So I can say def queue equals session dot create queue. And in this case, I can't use the JDD09 name. I need to use the actual physical name of the queue, which is jms.q1. Notice in the JDD09 I just used Q1, but I'm actually talking ActiveMQ directly now. Okay, good. Let's see, I have a factory, a connection, a session, a queue. What do I need? Oh, a receiver. Let's create a receiver. So we create that from our session as well. And I pass in the queue. Beautiful. Do I need anything else? Factory, connection, session, queue, and a receiver. So notice I'm not implementing message listener here at all. If I chose to implement message listener in this class, I would then have to override the onMessage method, which means I'm starting two threads, my own and a separate listener that actually has the onMessage callback. But just for simplicity and the fact that we want to get to some other good stuff, I'm just going to use a blocking receiver, a synchronous receiver. So what I'm going to do here is I'm going to start the connection. Okay, so I start my connection, and then while true, basically I'm just going to listen for messages. Let's do a print line, waiting for messages, groovy. There we go. Now I want to receive a message. Def message equals, and I just say a receiver dot receive. Cool. Right? What's this? Whoops. What am I doing wrong here? Oh, yeah. See, I don't need to debug. I just need all of you to follow me around everywhere I go to just check my code. I don't use debuggers. Good, and then just print line message. Dot get text. Cool, okay. And this will just continue to spin through forever. It's pretty easy, isn't it? That's great. That's all there is to the JMS API. Oh, there's a couple of extra exception classes and stuff, but that is pretty much it. So let's see if it works, actually. We'll come over here and start up the receiver. And it looks like it kind of just ended, didn't it? Yes, we started the connection while true. Receiver.receive. So this is why we should probably record it in a movie, huh? Let's send another message, and now let's do it. All right, so now we get to debug. All right, so I created, let's see, 61816. So, you know, Groovy ends up not like telling us very much about what's going on here. So we create the connection, we created a session, create the queue, and the receiver. All right. And I don't see any compile problems, but there must be one here. All right. I hate doing this, but let's find out why it's not working. Free JMS book for whoever figures it out before me. Okay. Nothing. Nothing at all. No, nope. No, it does not. Need to be public. So, and what? Oh, no, the script was fine. I actually ran it last night, but I don't remember a whole lot about last night. So, I see what's going on. I found it. Sorry, no free book to anybody. I was in the wrong package. I need to be in JDD. That's what's wrong. So let's type all that over again. No, no, I'm just going to Control V. There we go. And now let's receive those messages. There we go. Hi, JDD. So now I can send it and receive it. There we go. Yeah. Oh, boy. Okay. Pretty insignificant coding. But essentially what I wanted to do was, first of all, we need the receiver for when we actually are going to start sending stuff with HTML. But also, just to kind of show you how simple messaging is. The syntax of the JMS API is very, very simple. However, design is another story. So, a couple of design considerations. The first is message persistence. Okay. So by default, every message in JMS by default is persistent, which means that it is stored, usually in a database, it could be a file, for every message that's sent. It actually needs to be there in order to support guaranteed delivery. Right? If a message isn't persisted, then it stays in memory. If that messaging server crashes, my message is gone. That's why it's there by default. But it's important to understand the trade-offs that are involved. And the biggest trade-off is first, performance. As you can see on the red line here, this is a benchmark with WebSphere MQ running on Red Hat 4 on an IBM X series 360. So as I increase the number of clients, meaning pushing messages through the system, you can notice here I can get to about 4,000 messages per second. It's the fastest I can do. If I switch to non-persistent messages, look at that. Almost 11,000 messages a second. Yeah, message persistence is extremely expensive. So, the first design consideration to take into account is do I really need message persistence? In the event that my messaging server goes down, can I afford to lose those messages? That's the question to ask. If it's no, it has to be persistent. But there's a lot of messages that we make persistent that we don't need to, just because it's the default, or we don't know, gee, we can change it to non-persistent, for example. Okay? We can do that through the sender. It's done through something called a delivery mode. I could do it through a sender, or when I send a message, I can also set the message persistence. So, just by doing that one setting, I have almost 2.5 times better performance in my messaging system. That's pretty significant. Okay. Another cool design that I come across quite a bit is what I call the single queue design approach. This is creating an application with just one queue. Okay. So I have book orders, for example, order status, and cancel order messages all coming in through the same exact queue. And then I have 20 listeners listening for those orders, or status, or cancels. And this delegates it, or acts as a router, to go to the order processor, the status processor, or the cancel. As a matter of fact, this might be what the code looks like for the router. It's a very common pattern. We have our on message, so this is an asynchronous listener. We grab the XML out of the text message, so you can see we're doing right here. If the type, and then we grab the type, which is our own property. If I have a new book order, then I execute this, so on and so forth, okay? So that might be what the router actually looks like. So it's a surprisingly common pattern, and there's a lot of good reasons for it too. For example, some of the advantages, well, it is very decoupled processors. Think of this. Each of those processors only take in XML. That means I can test those outside of messaging. I can use those processors in any type of system. It's just a Java Pojo that takes XML. All the messaging work is being done by the router. That's what I mean about decoupled processors. It makes testing very easy. Maintenance is very easy, because you know how those MQ administrators can be, right? No one here is an MQ administrator, right? No. Try to get them to add another queue or message channel. Oh, forget it. What if I needed to add another type of message? What do? I add one if statement to the router. I create my schema, create my Pojo. Boom. Nothing to do whatsoever with messaging. So it's a pretty common and very simple type of architecture. However, I maintain that it's not very good architecture. Why? Ooh, a lot of minuses. Poor load balancing, poor response time, poor concurrency. Our processors have to be Java, don't we? So we're using messaging here, but I can't really use .NET for this particular component here because it's being invoked from Java. Oh, I can add messaging in between here, and all of a sudden we get a really complicated architecture. And overall poor agility. Let me bring this back and describe exactly why all those things happen with this. We have 20 listeners. That means I can process 20 messages at the same time. I get a flood of order status in. Let's say 50 order status come in. And right after that, I get a book order. That book order is going to probably wait around 10 or 15 seconds before I ever get to it, because my listeners are busy doing cancels and statuses instead of book orders. The obvious solution, well, just use message priority. Ugh. We'll look at that in a little bit. No, don't use message priority. So the problem is we can't guarantee that we can process books, cancels, and status at the same time. A better design approach is to actually create a separate queue for each. And this is why I can fine-tune the number of listeners now. The number of listeners that we can have is generally limited. In my experience, around 20 is usually the limit. Now, this depends on hardware, the amount of memory, CPU, etc. However, 20 is usually about a good limit in most systems. So I don't have 50 or 100 or 200 processors available to me, or I should say listeners. So here, I can set up 20 listeners for book orders, all being processed at the same time. Status are very quick, so I only need 4 listeners for the status. And cancels, I only have 2 listeners here. Why? Well, we don't want people canceling books. So if they have to wait a long time, hopefully they'll just buy the book, right? So you can kind of see now I can guarantee that I can process all 3 types of those orders at the same time. Furthermore, I can set more resources on the things that are important to me, okay? Now, I mentioned priority. Oh, there's another aspect before we go on to priority. Performance again. Look at the performance difference as well. The bottom red line represents using a single queue. This was the same benchmark, using 1 versus the 3 queues. Look what I have just done to my system. Not only can I process book orders as fast as possible and at the same time as status and cancel, but I've just almost doubled the throughput of my system by using 3 queues instead of 1. Look at the difference. Up here, I can do almost 8,000 messages a second in this system. However, in the old system with just 1 queue, about 3,000. Big difference. So I want to show you that it's not a bad design to do a single queue, but it's important to know the ramifications, or the word I'm trying to think of, the implications of using it. There are some minus sides to it. Now, I mentioned don't use priority, but that's crazy, right? That's what message priority is used for. Let's take a look at message priority. So, we have this scenario. Orders, exact same order for a book. Here, books are being ordered through the web. People are waiting for them. We've already gone through several steps and authentication and validation, so these orders only take 5 seconds to process. Now, there's a special. Anybody who attends, let's say, a conference gets one of my books for free. Well, those all get batched up and put into a kind of a B2B batched orders. No one's waiting on those. You'll probably get the, really not giving away a book free. But if we were, then when you get home, you would get it in the mail at some point. So those are all batched. It's the same exact message. Okay. So, but those take about 30 seconds to process each. They're all going through the same queue, and I have 3 message listeners. Let's do the math. Okay. So at time 0, system is idle. T plus 1. All of a sudden, 20 batched orders come in all at once. At time 2, 3 of those batched orders get picked up by the 3 listeners. Immediately afterwards, we have 5 web orders for books coming in. Now, we have an SLA of 5 seconds, yet users are constantly complaining that it's over 30 seconds response time in our system. Why? Well, those listeners are busy processing those long batch orders. Even though we set priority high, they're still busy. So, web order 1 is going to take 35 seconds to come back. Why? 30 seconds to process that batch order, then that listener is free, it uses priority, and now that web order goes in front of all those 17 other batched orders. Web order 2 is 35. Look at this, though. I'd hate to be that fellow right there who has to wait 40 seconds. So one solution you might say is, oh, Mark, just increase the number of listeners. How many database connections do you have available? How much should we increase it to? 50. What if we get 100 batch orders in? The bottom line is this. Even if you have the same exact message, consider using a separate queue instead of priority. Or the other way I like to put it, if you're ever using message priority, stop and do the math and consider using a separate queue, even though it's the exact same message. Okay. I promised Anna that I would not be late for lunch because I know all of you are very hungry. So let me quickly go through, and I have 5 minutes left here, so we'll see how this works. I wanted to do a brief look at RESTful JMS. So, web services versus messaging. The reason I like messaging better than web services, it's easier, it's less complicated, it's more reliable, it's easier to monitor, and it's a lot more fun than web services. I don't find web services very much fun. I can still use SOAP, by the way, in JMS. So web services really becomes just the transport vehicle. So the bottom line is this. My recommendation inside the firewall, use messaging. It's more reliable, better monitoring capabilities. I think it's easier to code and to configure. And why are we using HTTP behind the firewall? Doesn't make sense. However, outside of the firewall, web services. So, this is a problem with messaging, isn't it? Hence the need for RESTful JMS. So just a quick 1-minute tour of representational state transfer. Really, this is an architectural style. Scott's going to be speaking about this in greater detail at the end of the day. But really, it's where resources are accessed through verbs and nouns. I tried to make this as simple as possible because it's kind of difficult sometimes to explain what REST is in 1 minute. Well, it really consists of 3 parts. What is it? Resources and representations. Oh, I want customer number 1, 2, 3, 4. That's what it is. The second question you ask in REST, where is it? Oh, it's right there. There's my host name, port, protocol, location of that resource. Great, so I know what it is, I know where it is. The third part is, what do I want to do with it? Do I want to do an insert, a delete, an update, or a read? And that would be right here with the get. So, right now, there are 2 providers that support JMS and REST. Before I get to that, though, it isn't a perfect match. There's a lot of problems with JMS and REST. For example, does a get on a queue remove the next message, or does it just browse it? Because don't forget, with REST, we're supposed to be what's called idempotent, which means we cannot change the state of the resource during a get. But we are with messaging, aren't we? How about a delete? Does a delete actually delete the queue, or does it pull a message off? These are tough questions. Okay. So there are 2 vendors that currently support REST, ActiveMQ and WebSphere. Okay. Since we've already been using ActiveMQ, let's go ahead and try it. So what I have here is 1 minute left, 2 minutes left. Good. Let's go back over to here and let's see. Oh, I think I already have Safari up. So I'm going to bring up a very simple web page. Here it is right here. How simple can that be? Okay? So what I'm going to do is put my listener here, so we're still listening on Groovy. All right, there's Groovy. And this is a simple HTTP web page. I'm going to say, and I don't know how to spell, oh yes I do. There we go. Touch JDD, and I send it, and there it is right there. Receive straight away. How these work is the providers themselves have servlets, which are now translating those gets and those posts into JMS calls itself. So all I need to do is a simple form. As a matter of fact, I think we have 1 minute left that I can actually show you. Oh, I better not. Anna will get mad. All these slides, by the way, that I've been showing as well as the code are up on my website. So I don't know if they're going to be distributed here, but you can certainly get them from my website. These are just some of the mappings and stuff. Good. So a couple of thoughts for the hands-on conference. We can do a whole bunch of coding. Some of my thoughts were to do some stuff with pub/sub. We can send images and documents. That's one of my favorites. We'll send some good old Polish vodka back and forth between receivers. How's that? That would be nice. We can send large messages. We'll send large bottles of Polish vodka. We can talk about transacted sessions and actually code some of this stuff. Message acknowledgements, durable versus non-durable subscribers, request reply messaging, messaging pitfalls, all sorts of stuff. The day is yours tomorrow, I believe. So anyways, a couple of places. My book just came out during the summer, the second edition of Java Message Service by O'Reilly. So it's updated with everything, including Spring, RESTful JMS, whole bunch of goodies thrown in there. There's also the source code as well. You can grab, and my slides. It's wmrichards.com/slides. And if you go there, you can get all the slides that I'm going to be talking about today. So anyways, I believe that it is exactly time to stop, so I will not hold you up for lunch any longer, and hopefully you'll see some more of you later on today during the anti-patterns talk. So, dziękuję. All right.
Teraz mamy kolejne 10 minut przerwy. Zapraszam ponownie o 12:05.